and we actually discussed various approaches of creating a data frame, where first we used the as.data structure to form a data frame. I also didn't save my R script, but I hope you guys have one. So we are saying that we actually formed a data frame using the so-called data.structure function. Data.frame to form the data frame, and then from there we were able to access the elements, or rather the variables, from there. Now basically we were saying a data frame is a list of vectors. If I can remember, we were defining a data frame as a list of vectors in which the individual vector is homogeneous, that is, it is of the same data type, but the different vectors that are forming the data frame are of different data type. That is basically what we were defining a data frame to be. And we went ahead and discussed about a table, and we were looking how we can convert a data frame to a table, and talked about some of the advantages of using a table compared to a data frame. Also, before we look at look at table, we also looked at other ways of creating a data frame, such as importing data, where actually we introduced how to import data, or rather different data files, to R Studio. And one of them is the CSV file, where we were using the read_CSV function, and we talked about the differences of the read_CSV and the read.csv. We talked about those. Now we actually imported our data, and all of us were actually doing that because I was actually taking time to make sure that we are all able to import our data. And one thing we realized is that when we were using the read_CSV, we were actually getting the data as a table. But in our previous discussion, we were actually saying that a table is just a data frame that now prints with sanity. That was the comment I was putting the other day. So when we use now the read.csv, it is now imported as a data frame, a normal data frame for that matter. And we said the two main advantages of the read_CSV is that one, it is importing the data as a table, and it is faster compared to the read.csv when it comes to a large data set. Now we also said to use the read.csv, then we need to have the library readr. We install the library and everything and all that. Now today, before we look at something else, I just want to finish on a small part, and also to give a very small assignment on the same, and this is subsetting a data frame. Remember, we were creating a data frame, but we were not subsetting a data frame. Now when we were looking at a data frame, we are looking at many observations and many variables at times, not always the case, but in most of the cases. Now let's have this one data frame that we are able now, or rather we will be using to subset and see how we can access a portion of the data or some elements from that data frame, or a table as well. Now to do that, we are not going to import data, but actually we said we are going to use data in a library. The other time we were introducing about libraries. I don't want to go back to that, but we introduced the libraries and explained everything. And actually we had started and saying there is one library that we will mostly use when it comes to data visualization, and that is the ggplot2 library. Now we said in a library we have functions and datasets that we can use. Now the ggplot here is very famous package that is mostly used in data visualization, but at this point We are only interested to use a data set that is there so that we can simulate how we can subset a data frame. So first thing that I'll do is to load the library. You guys remember that if we want to get a book in the library, then we have to go there. So let's go to the library and have our ggplot2 library. Now when we have this library, we can actually access the dataset that is there by calling its name. Now this dataset we were mentioning last time is called the MPG dataset, and this is a dataset for record of information about cars in fuel consumption, different brands of cars recorded in different period of time in terms of years and all that. So when we call this data, you find that the data is printed. Now one thing we notice is that this data is in table format. That is why we have a table with 234 rows. Those are what we call observations, and 11 variables. Now you find that normally before we do any analysis on data, we first need to understand the data. Now it all depends. In a case where we are using inbuilt data, there are some questions we need to ask ourselves. But more generally, when we have data, three most important things that you need to know, or rather to have a look at so that you can get to understand the data, is number one, looking at the raw data. Like you scroll on that data, you observe the data, and you get some understanding of the data formatting, how it looks like and all that. Like from here we can at least get an idea of how our data looks like. And this is what I'm doing when I write MPG data. I call the data is basically I need to have a look at the raw data. Now two is understanding the data, like where did the data come from, what are the variables in that data and all that. Now mostly when we'll be using real world data, you find that you'll be provided with what we call data documentation, and this will give more information about where the data come from, what are the variables are there. Suppose the variables are abbreviated, what's the name of that variable and what is it representing. But now for this case, because this data is in a package, we can actually get the documentation by asking for help. You guys now know how to ask for help. That is why I put the question mark, and when we run, we have a documentation of the very same, and we can see here it is saying fuel economy data from 1999 to 2008 for 38 popular models of cars. So you can read about the variables, what they represent. Like you can see model, that is model name, year of manufacturer, and all that and all such. Those are the things that are there. You need to understand as well. Now after you have understand the data, then I guess the next thing you can do is maybe doing a visualization and such, but we're not going to focus on that here. Now you realize there are also some functions that are most famously used in doing sorry, someone is okay. So they are functions that are mostly used and help us to understand our data. Like for instance, we actually have 18 minutes to finish this. Is it 18? Yeah. To understand our data, there are these functions that will help us in understanding our data. Like one, we have this function called the header function, and it is in the utility package, and this one will return the first or last part of an object. So like for this case, it is data. So when we use this header, at least we'll have a look of how the data is. But I'll tell you at this point, this function is not that useful, and I'll tell you why. So in this function, you can still ask for help and see how you can implement the function. But basically, you pass the name of the data, and then you can specify the number of observation that you want to observe. Just have a look of how the data looks like. If you don't specify well and good, there's a default value that is assigned. Now when you run that, it is giving you this information. Now when you look at this information that you are getting after we have run the header function, it is more or less the same when we call the data. Now the only reason as to why it is more or less the same is because our data is in table format. Otherwise, if it were a data frame, then we were not getting this. So we are only getting this information because it is a data frame. Now still there is some difference. Despite that, we are getting the number of observations, the data structure of the data first. You can see it is telling us it is a table. Now the data frame is telling us how many observations are there and how many variables are there. But this one is specifying the ones that we had actually asked for. Now also, you find that in the data table, we are getting the number of rows that were not printed. How many more observations are there? You can see it is telling us that 224 more rows are there. That is the difference. But still you can see that we have these variables name, the variable type. You see, like this one, manufacturer is character, model character, year is an integer, and all that. We are getting the data type. So that is one function that can be used to get more information about the data and see that function. Also, you can decide to use the structure function. The other time we're talking about the structure function. It is also used to explore what the data entails. So when you run the structure function, you get like more information, a display of the structure of the data you are dealing with. So you can see here we are it is telling us that the data structure is a table, and it has 234 rows, which are the observations, and 11 columns, which are the variables. We also have the manufacturer. These are now what we call the variables that are there, and also their data types, and some of the observations, how they look like. Now, under normal circumstances, if we had imported this data, you would find that this information will actually found on the environment. We will have this same information on the environment here of our R studio. That is also always there. Now also, suppose you want to know the names of the variables that are there, we will use the names, and this is in base R package. So when you say names of the dataset MPG, you are getting the variables name that are there. Very important, because now and then maybe you want to access a certain column, but you don't know the name, or you misspell the name. So when you have a look at them, you can even copy and paste the name as you call that particular column. So that is it. Now let's now finish our discussion on what specific we want to talk about. That is subsetting the data frame. You see, we have this data frame. Suppose we want to get a certain elements. But before we look at subsetting a data frame, let's talk about accessing a particular variable. Like from this data frame, this table, I want to access, let's say, the manufacturer only, the column manufacturer. Now when we talk about this, you find that we are accessing one variable, and we are accessing one variable as a vector. Now in this case, we have several ways of accessing. Actually, we discussed this. We can use the $sign, we can use the attach, we can use the bracket, and all that. We did this in last lesson. We can use the square bracket, the name and the square bracket, and then we specify. We can use the attach function, where we attach the data, the name of the data frame, or rather the table, and then now we just call that particular row, or that particular column, or rather we can use the $sign. So if we say MPG, and then you have the $sign, you can see they are all listed, and when we call manufacturer, then we have the data for the manufacturer. There is actually one way, and we did that last time. So still you can decide to attach MPG and then you call manufacturer. Still you can use MPG, you open the bracket and you have the index of that particular column and you can access that. I don't want to go to repeat that. Now let's go back to what I want to discuss because of time. I want us to access a portion of this data. Maybe we don't want to do analysis with the entire data set as it is, but we are only interested in a portion of this data. Let's give an example of, let's say we want to focus on analysis of the data. Now it is at this point you need to understand the variables. We have the year of manufacture, we have the highway miles per gallon. Now we were talking about fuel consumption, so let's talk about the highway miles per gallon or the year of manufacturer. Maybe we are interested, we want to focus our analysis on those cars that were manufactured between 200 or let's say 200 and above. So from this data set we want to subset and have those cars that were actually manufactured from 200 and above and focus on our analysis on that particular data set. In the same way, one might be interested and say, no, if suppose now it is important we have a look at these variables we're talking about. Let's try to call the year of manufacturer, let's say year, and see the years that are there. You can see we have 1999 all the way, I guess, to still you can ask for the highest value. I mean, you can ask the max in that and you get. So you can see, but we have 200s all the way to 2008. That is by inspection, but we can ask for the maximum. Now you know how to ask for the maximum. Or we are talking about the highway miles. So I can say the maximum. Now I have to do this one. Let's say the maximum for the highway miles. That is highway miles. So when I run that, you can see it is 44. It is 44. That is the maximum. But when we run now, let's have a look at where it is starting before, so that we can have an idea of what we will be doing. So yeah, we can see the values starting from all the way 12 to 44. That is by inspection. I'm looking the minimum by inspection, but you can actually decide to check for the minimum. Now, this is what I want to do. I want to access the elements. I want to subset this data here, the entire data set that we are having, so that we are only focusing on those cars whose highway miles per gallon is above, let's say 25. Is above 25. Now we want to subset that, have that data set, and then do our analysis. That is now what we call subsetting. So you realize at this point, the other time when we were talking about subsetting a vector or even a matrix, we were talking about subsetting based on index and subsetting based on condition. So at this point, I hope you can see that we are more of giving a condition that we are using to subset. So how do we do that? Now actually, there are a number of ways of doing that, and I'll start. We are only going to discuss maybe two because of time. And to do this, okay, which one should I start with? Now let's start from this one. You find that subsetting data frame, because this is a data frame, works more likely like subsetting a matrix, and that is using the square bracket. When we were subsetting a matrix, we are using the square bracket, and in that square bracket we were giving the row and the column. That is in the case of a matrix. Now look at this, we still have rows and columns. I guess we can see that, only that we are looking at the rows as observations and the column as the variables. That is what you want to remember. That is what you need to remember. But still, we can use the concept of matrices and the square bracket to subset. And this is what I'm talking about. So I'll have mpg, the square bracket. Now from this square bracket, we can specify our condition. So we are saying we want those cars whose highway miles is greater than 25. That is what we were saying. So I can say from that data mpg. Now you see the first one, mpg, is now for the name of the data frame we are dealing with. Now inside that square bracket, because look at this, before I write anything in that square bracket, if we execute, it gives us the entire data set. Before you write anything in that square bracket, I hope you can see that. When we write mpg and a square bracket, it gives us the entire data set. Only that it is not printing everything, but it is actually giving us everything, because you can see they are saying that these more rows down there. Now, when you write something in that column, in that square bracket, if it is an index, it will give you the particular column or row you are specifying. So let me try this. Let me try this. Remember matrix, when we're doing matrices, they are two-dimensional. So you need to have a row and a column. So I write one and I put a comma and I execute that. You find that it is only giving the first observation. That is still subsetting. But now we are using the index. Now if you say mpg and you put a square bracket, then I put a comma and I put 1, you realize it will give the first column. You see, this one was a row and this one is a column. This one is a row and this one is a column. So I hope you are connecting the dots with how we were doing it in matrices, because this one is two-dimensional. Now you realize in doing analysis, this one is not applicable as such. I'm not saying it's not applicable, but in most of the cases you are not going to use this type of subsetting using the index, but rather you'll be doing subsetting using a condition. And this is where we are talking about the operators and all that we are discussing. Now let's look at it. Let's look at it this way. We want to access the elements whose highway miles per gallon is greater than 25. That is what I said. So I'll say mpg like that, and I open the bracket. Oh, I forgot to write the comments. You guys can write the comments. Subsetting a data frame. Now what we do, we are actually now not dealing with an address, but a particular column to give a condition. So we'll say in that mpg, the column highway miles, if it is greater than 25, now select it and I put a comma. Look at that. Now this one, what is doing is it is coming to this data set, the entire data set that we are having. Where is the one with the bracket? This one here. It is checking if the highway miles is greater than 25 here, and then because I've put a comma, now you can remember here, when we put a comma without specifying the columns, it will print everything. So this means that it will come here, look for that highway miles. If it is greater than 25, it will print the manufacturer, the model, the display, the year, and all the rest of the columns. So we will execute that, and we have it. Now when you observe here, you find that the highway miles are actually greater than 25 for all this data set. Now you find that at times you have done this subsetting, but you even want to reduce more and more to dwell on only few columns that you want to focus your analysis with. So let's say, and this is still the concept of subsetting matrices. Let's say we are not interested with the class. We are only interested with the manufacturer, the year, and the model of the car for those cars whose highway miles per gallon is greater than 25. So we are leaving, it is at this point Mr. Rashid Mwalim would say, we are leaving class, city, and the rest. So how do we do that? No, it is like we are adding something here. So we'll say, instead of printing everything, we'll specify the columns. So we'll say, because of time, allow me to be lazy, I'll just copy this and I'll paste it there, and then we add. So you find that we don't want everything, but we want only a few columns. So because we want a few columns, if it is one, you will just write its name. But if there are more than one, you'll have to use the combine function. So I'll write the combine function, and because they are column names, I'll have to quote them. So I would say manufacturer. I would say manufacturer, like that. I hope it is as it is. And then I'll say maybe year, and then I put a comma, and lastly I say the model of the car. Maybe we want to subset and only focus on this so that we can have our analysis on that. And when we run that, you find that we only have the three. Now we have left out class, fuel, city, driver, and all the rest. So I guess from here you are getting the next approach of, now instead of listing those that we want, we can list those that we don't want, and we negate outside here. The same way we were doing for matrices. Now that is one way of subsetting a data frame. Now the other way, just to wind up, the other way is by using a function. There is a function that we can use in doing the same, and this function is called the subset. So alternatively, we would use the subset function, which is actually more readable in terms of the syntax than this. You see, unless you have a comment here, someone who is not that vast will not understand, but definitely still many people will understand this. I mean, many people who are familiar with R. But when we use the subset function, it is actually easier and more readable. So let's do the same using now the subset function, and this is what you will do. So you'll say subset, and this is a function that is found in the base R package. So we are doing the first one, this first one, where we are getting all the information, that is the class, the manufacturer, the city, the model, for those whose highway miles per gallon is greater than 25. So in this, there's a documentation because it is a function. You can don't forget to ask for the documentation. You can see the syntax, the arguments that are there, and everything. Now when you use this subset function, the first argument that you need to pass is to specify the data that you want to actually subset. So my data is MPG. So I'll write MPG and I put a comma. Now you need to give the rule. That is the second argument. You can see the second argument here is X is the data. Then we have subset. That is the argument that we want to pass. So we will say subset as an argument. What do you want to subset? I want to subset those whose highway miles is greater than 25. Is greater than 25. Now you see we have other elements like select, drop, and all that. But because we want to achieve the first one, we are not going to include the component of selecting here because we want all the properties. So we'll just execute that. And this one is actually doing the very same thing this other code was doing here. This one was doing here. I hope that is okay. I hope that is okay. So if we were to do the second one using the same, now I'll copy that. Allow me to be lazy. What we are introducing is now the select argument. Someone is saying something. Guys, if you don't understand, just unmute and say something, because I'm not on the meeting. Kuna mtu ananifukuza, so yeah. So if you don't understand, just unmute and say, hey, can you pause or something. So we want to repeat this second one here, so that we can only select the manufacturer, the year, and the model. Now to do that, we now pass the select argument like that. And now in this select argument, you will list all those columns that you want to get. And these are the columns. Because of time, allow me to also copy these ones. You can still copy that, and that will be your function now to select all those columns that you want. So when we execute, we are now getting that. There is another way that you can subset a data frame. And when we say a data frame, we are including a table, because basically a table is a data frame, only that it prints with sanity. It is more precise. It has some advantages and all that, the things we discussed about. Now one last, this is the last one, is now using the pipe operator in doing subsetting. So before we use this pipe operator, allow me to also, we will combine the pipe operator with functions to achieve what we have been subsetting here. Now the pipe operator, before I talk about the operator first, let's talk about the filter and select function. Here we are using the subset and select. Now we will use what we call the filter and select functions. So one will be used to filter, and to filter is like providing that command, that condition. So we are selecting a portion of data based on a certain condition. We are filtering the data set in that case. Now selecting, after we have filtered, we are now selecting some components of whatever have been filtered, so that now we can use it. The same way, actually, this is just like this one. This one subsetting here, where the higher number is greater than 25, this can be said to be like filtering. We are filtering from the data set. Now this one is selecting. So we want to use the same functions, but now this is not subset. It's not subsetting now. It's filter and select. Now these two functions are found in a library called dplyr. They are found in a package called dplyr, and it is also commonly used a package also, though not such, but it is widely used. So we need to load this library. So if you have not installed, then you have to install this particular library before we can use the filter and select a function. Now you know how to install a library. So install library dplyr. Now also we are going to use the pipe operator. Now this pipe operator, the one we are going to use is from the Margaret package. So we will also load this library, even though it is not that much useful in here. At this point we'll be using it, but as we proceed, now and then we'll be also using it. Now piping, talking about piping, and this is the operator. Maybe just to show the operator that you're going to use. I'm happy to say the other day I was seeing Humphrey sharing a documentation of about piping and the update on it. You guys should have learned that from the documentation. But basically, piping is an idea that was actually, I was reading this, there's a book I was reading and it was telling me that piping is an idea that was taken from the Linux shell. Now what piping does is that it allows the output of one expression as an input of another expression. That is what piping will be doing. it is taking the output of one expression and make it available as the input of another expression. We are going to discuss that and you will understand that even clear. So let's load the required libraries. Let's load the required libraries. If you have a challenge, you can reach out and we will look at that. So we are loading the dplyr package. I hope all we have it. I hope we all have that package. If not, just write install.packages dplyr. Remember the name, you must quote the name. Also the library, the Margaret library, but this one, okay, let's just load it, but I guess it could also work. Now, having those two libraries, let's see how we can now subset using the pipe operator combined with the filter and select. Now, when we say mpg, this is the data we are all seeing. This is the data. We have the entire data. Now, we want to take this data, make it available so that we can now filter this data. So, to do that, we are using the pipe operator. So it is taking this data, you see when we run this, we are getting this data. So this is the output. So it is taking this data, making it available for the next analysis you are going, or the next expression you are going to do, or rather the next analysis you are going to do. So it is taking this output, make it present as the input of the next expression. Now what is the next expression is filter. So from this what we have here, now filter, you see it is in the dplyr package. What are we filtering? Filter those values whose highway miles per gallon is greater than 25. That is what the filter, the pipe operator is doing. When I was running this mpg, it was printing the entire data set. So this is the output. Now from this output, make it the input in the filter function and filter the values whose highway miles is greater than 25. Now this, when we execute this, it will give us the output of the first. Because we are not specifying the columns to select, it will now give everything. But only that the highway miles are those that are greater than 25. So this one actually is this first, which is the same as this. The output is the same as this. And we have it there. Now what about when we want to have this second command here, when we are only selecting specified columns, like the same with this? How do we do that? Now allow me to copy this, because the first one will be like that. So what happens here, just to explain what happens, is we are taking the mpg dataset. When we execute, you are getting this dataset. This is the output. Make it available. We were getting these actually. You can see their values here greater than 25 and all that. Now from this entire dataset, make it available for the second expression as input. And from that, filter those values that are greater than 25. And now it was printing this. Now from these values that are greater than 25, the highway miles are greater than 25, it is printing the entire column. Now take this as the output, make it available as the input to the next expression. Now to do that, we need to pipe. So we will have another pipe so that we can take this output here now, make it available for the next expression. Now in the next expression, now select. Now select. Now what are we selecting? We are selecting the manufacturer. The year, and the model. Now because these arguments are passed in a function, we are not quoting them, because we are accessing the individual column. And what you can note is that when you start writing them, like the manufacturer, they are popping up. And actually the reason as to why they are popping up is because of the pipe operator. It is taking the output of this, making it available as the input. That is why you have this suggestion. So I'm taking the manufacturer, I put a comma, I also want the year, and it is popping up, I'm selecting that. I also want the model, and it is popping up, and I'm selecting that. Now when you execute this, it will give you the output like what we are getting from this command and this command. The pipe operator, the filter, and the select function from dplyr and the magnet package respectively. Very, very important about this filter, about this pipe operator. Now and then it is commonly used. I myself, I love using this mode of subsetting than these others. I mean, it is, I find it to be more reproductive and reusable compared to this. So these are the three ways we can use to subset a vector, a data frame. So these are the three ways we can use to subset a data frame. So you can see all the approaches here produce the same results. Now, which one to use will depend on a given situation as well as your preference. That is now up to you. That is now up to you. So any question up to that point? Any question up to that point on subsetting? If you guys understand this, I just want you to type a 1. If not, you type a 0. Just type a 1 or a 0. I can see Karim is saying a 1. That is awesome. I mean a 1. Yes guys, let the 1s and 0s come. The rest, where are we? I mean, you guys should respond at least. Patience, faith, okay, Karim said, grace, Mary, and the rest. Let me see the 0s and 1s. Oh, I can see Saif is saying, yo, it's cool. Yeah, faith is cool. So, yeah, I can see our professor is here and is pointing, yeah, thumbs up. Thank you. Now, yeah, I'm happy seeing the 1s. So you find that when subsetting a data frame more generally, first, be aware of what is being returned. Be aware of what is being returned. When you look at that, you see our data frame is a table. So whenever we are subsetting, in most of the cases it was giving us the output as a table. But look at this one here. When we were accessing, which case? Come on, yeah. Very fast. Okay, I didn't do that. But I was saying generally, be aware of what is being returned as the output, because you find that at some point, or rather times, it may be returned as a vector instead of a data frame. Now this is a table. That is one advantage of a table. But at times a data frame, it can be returned as a vector, and now you start having a rough time of accessing the rest as a table, and it is printed as a vector. Now also note that there are differences when we are subsetting a data frame and a table at some point, such that you find that a data frame operates more like a matrix, as you can see. And when now we are accessing the elements, it is more easy to subset like a vector. Now when it comes to a table like this one, it will now operate like a list, where we are always subsetting to get another table. So if it were a data frame, you could find that some of the output is printed as a vector or something. So it is always good to have that in mind. Now with that said, I guess I've come to the end of data frame, and more likely on data structures. So I have only one assignment for you. We have one data structure that we have not mentioned, and I have a reason, is because we have mentioned two that are similar. we have this one called data.table. You see, we're talking about data.frame and a table. .table. Now this one is table, but this one is table. T-A-B-L-E. Data.table. So I want you to go read about data.table, read and understand, and you find that it's more like a data frame, but it actually has more advantages. For me, I would say it is an extension of the data frame class, and it actually has different and unique capabilities. And some books would say, and it's not actually books, but the fact is that it has been proven to be faster and easy to use in data manipulation than the data frame. So go and read, go and do it, go and read about it, and you even find that it is actually even different. You see, when we're importing data as a data frame or as a table, for a data frame we're using read.csv. Now for this one, we are not using read.csv to get the data as a table. We use the thread function, that is FREAD function, and it has a library of its own. So go read it, go read and understand, because it is actually very, very useful. And those are some of the advantages: more faster, easy to manipulate, and it is good at joining. At doing joins. When we're doing join, when we'll be joining data sets and all that, you have this data set you want to join with the other one. It is mostly more effective compared to a normal data frame. Well, with that said, unless there's someone who is having a question, if not, we are done with data structures. Now the next thing that we are supposed to discuss in this first introductory part is like basic programming, where we are to discuss functions, things to do with the loops and such. Now, like I said the other time, these classes will be teaching two of us, me and my professor who is here. So allow me to introduce and to welcome my colleague to take over on data. The basic programming on functions and flowcharts and all that. He knows. Definitely he knows what he's supposed to do. I don't have to even to mention such. So Humphrey Kinoti, I guess the floor is yours. You can take us through, and I'll be happy to be your student today. Welcome.
Thank you. Thank you for this opportunity. I'm Humphrey, and I'll take you through loops and functions. Now you have taken a lot of time. I was like, I leave that thing alone, and I'll continue.
I know that. I sensed that.
let me do just a recap of what I said. Maybe on the pipe operator, I'll be very fast. Okay. An advice for this. Ali, you are recording the screen?
Yes, I am.
Hello?
Yes, I'm recording.
Okay, thank you. Okay, let me first of all say that I'll be very fast, and if you are learning by coding, you are doing by coding. Maybe my teacher once told me that first of all listen and understand, then do it. Okay, in this presentation, I urge you just first of all just listen what I'm going to present. Just try and understand. After the class, go through the coding and write the codes. Now let me just share and just elaborate on something here. I did not say we are two of us. I have my friend just here beside me. So if you see two Humphreys, don't get panicked. I have my friend. I'll introduce my friend later. Okay, this is as Ali was explaining. I was just trying to do an overview of the pipe operator. There are two pipe operators. There is a magritar pipe package. From the magritar package, Marketer package is inside the dplyr package. If you load the dplyr package, automatically marketer is loaded. Okay, and this is how it works. The data, it goes to the first function. Those who are familiar with simple mathematics, there is something we wish to call composite functions. Now this is how the pipe works now. Now, for example, in this case, it will do an f. Let me just do a simple, sorry for those who did not study them, who have not gone through the mathematics. First of all, it will do the f3. That's the first thing which it will do the data on the f3. For example, let me show you using this syntax. First of all, it will do the f3, then which is the data. After it do the f3, it does the data is taken now again to the f2 function. This is what we used to call composite functions. And then after it does f2, it does f1. Now this format is the same as this one. Okay, for example, in this case, let me just do a fast recap. For example, in this case, I have created a variable called merge filtered, and then the MPG dataset, and then I filter the manufacturer is equals to Audi. Now, and then I select the manufacturer and the model, and then I arrange them into a descending order. Okay, what's the difference between a filter and a select? Now it's quite confusing for some beginners. The filter works on the rows. That's the simplest way that you can understand. The filter works on the rows, and the select works on the columns. Let me just try and view it. PPT. Yeah. Now, for example, now if you want to filter, it's just I'm filtering the rows. I'm working on the rows. For example, I want Audi. These are the rows. Now, if I want to do a select, I'm selecting the columns. Manufacturer, model, display, year, whatever. Now that's the difference between the select and the filter. The filter is for the rows. For example, in this case, I want to select filter where the manufacturer is Audi. Now here, the manufacturer is Audi, and then and select these columns, the manufacturer and the model, and then I arrange them into a descending column. If I run this command, automatically it creates. Let me clear the screen, the showing environment. Yes, sure. Now let me run the code. Now look at what I did. Select the Audi, filter the Audi only where the manufacturer is Audi, and selected the manufacturer and the model. That's the main difference between the select and the filter. Again, he's using the sorry for the distraction. Someone just entered the door. Okay, next, how to type this one. You don't have to type percentage greater than percentage. The shortcut for this command is Ctrl+Shift+M. You just click on your keyboard, Ctrl+Shift+M on RStudio, only on RStudio. It won't work on the app. It will automatically bring the pipe operator from the dplyr. Again, there's another type from the dplyr package. Okay, it does the same thing. Now, the difference is that this one starts with the data at the left, and this one starts the data at the right. Now look at this example. I started F3, then F2, F1. In this one, it's F1, F2, F3. Okay. If you have time, just go and understand about this. I have a lot of work to cover. Therefore, I won't be very much on these. Now let me run this code. I've labeled this as MPG filter 2. Then I've filtered. Okay, sorry. MPG filter 2. Yeah, it is the same output, but using different approaches. There's the baser, this one, and this one. Okay, that's all. Maybe if you have time, you will go through that. Okay. Save. Now let's go to the next task. Yeah. Desktop presenting. Oh, sorry, yeah, sure. Not the entire screen maybe. So let me share now what I'm going to. Today I want to discuss about loops and functions, but I don't know, the time won't allow me. Time won't allow me to do all that. Now let me in the presentation. Yeah, I made some slides which I'll be using for this class now. Okay, I'll go through the loops and functions in R. And as I said, I'm African. I'm a data scientist, a BI analyst, and again I'm becoming software engineer. BI analyst is a business intelligence, uses Power BI, SQL, and other to give insight on business. Okay, the main objective for this is to understand the loops and functions in R, to know the syntax and usage of different loop types, to explore the control statements within the loops, to create and use functions in R, to apply loops and functions in practical examples. We'll do some practicals, and then again we'll gain confidence in using the loops and functions. Okay, I hope that you'll be able to understand. Next, okay, what's a loop? What's a loop? Okay, this is just a basic introduction on the loops and the functions. Okay, loops and functions are fundamental concepts in programming. They allow us to automate repetitive tasks. For example, let me use a loop. Instead of doing this and now and then, just of repeating the same code one after the same time. After you run it again. After you run it, no, you use a loop, and the loop automatically does it for you. Okay, in this presentation we explore different types of loops, functions. Okay, I'm hoping that I'll be able to just to complete the loops. I can see that the time is not on our side. Okay, now let me begin with loops. What's a loop? In the field of programming, loops are used to repeat a block of codes multiple times until a specific condition is met or a specific number of iterations is reached. What an iteration? Iteration is like the sequence. I've provided a picture here, which is now after one complete oscillation, that's one iteration. Another oscillation, that's another iteration. Now loops, you can specify a condition that after this condition is met, stop. After this condition is met, stop. Or after you make this number of iterations, stop. Now that's basically what a loop does. In this case, we are going in loops. R has three types of loops. There's a for loop, there's a while loop, and a repeat loop. I've arranged them in the order of importance. For loop is very important, very much important. While loop and repeat loop. Okay, I'm assuming you all understood about the data structures and the data frames. I'll just focus more on those places. So if you're not good at that point, maybe it's good that you refer back. Okay, let me go next. I'll start with a for loop. Okay, now what does a for loop do? Okay, now this one, it iterates over elements of a list, a data frame, vector, matrix, or any other object. Now this is why I say that you must be good in data structures. In data structures. Now you must be very conversant with lists, data frames, vectors, matrix, and even sequences, to create sequences in R. Okay, now what does it do? A for loop. Okay, a for loop, it executes a group of depending on the number of elements in the object. Okay, a for loop is executed if the text condition is false. Now note as this, it will be executed if the text condition is false. Now this is a simple syntax for, let me just call a variable. These are random variable name in elements. Elements I refer to these, the list, data frame, vector, matrix, or even a sequence or any other object. Now these are the elements that I'm talking to. Then the statements. Okay, let me go just to the next slide. I hope you're able to get more, to understand better. I've provided a more more detailed syntax. Okay, just understand that the body will not be executed if the text condition is false. So it executes if only if and only if the text condition is true. Okay, now let's do this. Now this syntax of a for loop. A variable takes items iterate one by one. Okay, for example, let me use a vector. Let me use a vector, the simplest that I can use. A vector contains many elements. For example, let me use the numeric 1, 2, 3. Let me use a vector that contains 1 to 10. Now for a var, I assign var anything. It's just a random variable in iterable. Iterable is now the list name, the vector now that I'm doing. Then it executes the statements now. Now if that element is in that vector, then that's when it will execute the statements. Now let's take, for example, if I have a vector, let me just try and see how I can add some notes here. How do I add in some notes? Is it here? No, not really. It's here. Comment. No. Comment here, sure. Let me just do a comment here and say that no, I think this will not help. And so it won't help. Let me add a shape and let me just use this one. But I won't use the same color. Yeah, sure. Okay, now let me say a vector is, for example, a vector containing 1, 2, 3. Let me just say 1 to 10. Let me say 1 to 10, for example. 1 to 10 means from 1 to 10 inclusive. 1 to 10 inclusive. Okay, now we assign var a random. It's a random letter. For example, var is any variable. Yeah, it's let me say a variable. Now what this variable does, it goes and takes 1. Is 1 for example, is 1 in this list? Yes. If it's in this, in this vector, if 1 is in this vector, then it will do the statement. It will execute the statements. Then it goes to 2. If 2 is in this vector, it will execute the statement until 10. Now when it reaches 10 is in this vector, it will execute. Now 11 is not here, therefore it will stop executing. Now that's the condition now for the for loop. Now let me go back to the chart. Let me go back to the meeting now. At a scale of 1 to 10, rate what you have, if you have understood about the syntax of a for loop. 1 to 10. For example, for my case, let's say 10. Kindly. Hello. Thank you, Ali. Okay, it seems that they are not with us. 5. It is 5. Anyone else? Thank you. Okay, 2. Okay, that's enough. 2, 5. Oh, I'm quite discouraging, but I think I'll do an example. I think an example will help us to understand better. Okay, now let me go to the next slide. Now this is the flow chart. We initialize is the last item in the, for example, in the vector reached. If it is not reached, it will execute the statements. Again, if it's after executing this, it goes back to the condition. It takes another element. If the last element is not reached, it executes the statement. That's it. Now When the last element is reached, it executes the loop. Let's go next. Now let's walk the talk. Now let's go to R and do some practicals. Okay, as I said, I joined with a friend of mine. Now it's time to introduce a friend of mine. Unfortunately, the friend cannot talk. He can only do. He can only talk by doing. Let me stop presenting. Now I'll start with this one, with a sequence 1 to 4 print I squared. Now let me first of all explain before we do it. Now what this does for I in 1 to 4. 1 to 4 it is 1, 2, 3, 4. Print I squared. Now what it does, I
don't think you can see that screen that you're presenting.
Okay, I'm presenting the slides. Can you see the slides?
No, I'm seeing the screen that has R, but it's not moving. I don't know whether it's me alone. I'm not sure.
Now, Grace, what you can do, just leave the meeting and then join.
Okay.
Okay, we are waiting for you. Yes. Can you see the slides?
Yes, now I can see.
Thank you. Okay, let me begin with this sequence for I in 1 to 4. Then print I squared. Now what this does, it will check is I, it is the variable which, for example, is, which I said they call it var. Now what it does, it's the one which iterates inside this sequence. For example, in the first case, I will be 1. It goes in this sequence. It takes 1. I takes 1. After it takes 1, it takes a value of 1. 1 is inside this sequence. Yes, if 1 is inside this sequence, it will print 1 I squared, which is 1 squared. It goes back and checks the condition. Now it takes I, it goes to the next in the sequence. The next is 2. Yes, 2 is inside the sequence. Now since 2 is inside the sequence, it goes and executes the statements again. Then 2 squared, which execute 4. Then it goes again 3. The same 3 in the sequence. I is the same 3. Then it goes 3 squared, which is 9. Then lastly 4 is in the sequence. 4 squared, 16. Now after it takes the last element in the sequence, it ends the loop. Is that clear? The scale of 1 to 10. The scale of 1 to 10, kindly. Okay. Thank you. I see safe. Hello, safe. My long-term friend. Okay. Let me go back. Let's continue now. Thank you. At least I can say now. Now let's go to R. Let me stop sharing this screen. Sorry. Where is the meeting invitation now here? Oh, sorry. Yeah. Let me stop presenting these. Now let me present the screen. Kindly confirm if you can see my screen. Just put a thumbs up if you can see my screen. Thank you. Okay, now He is my other friend, my friend who can't talk, who can neither talk nor do. He can only work by doing. Okay, let me. Go to the let me create a new folder now. Let me just open it here. Let me make a new directory. One more data consultants. Yeah, sure. Let me go next to that folder. Let me touch. Confirm if you can see my VS Code. Use a thumbs up. You can see my Visual Studio Code. Thank you. Now this is what I'll be running the commands. Now it's a for loop. Let me just start by adding just a simple comment. For loop. Now let's start now in the for loop. Now okay, it started. Now let me say for. Actually I have an I which is doing that for me. Now let's guess what this function will do. For I in a sequence of 1 to 10, you print I. Now let me do I squared. Now what will you expect it to bring as the output? First of all, it take I to be 1 and then it square 1. Okay, let me run this command. Look at what it printed. 1, 4, 9, 16 until 100. Now what it does, what it feed, it 1 is assigned is inside the sequence. Yes, 1 is inside the sequence. 1 is squared. It prints the square of 1, which is 1. Next it's 2. 2 is inside the sequence. This 2 is inside the sequence. It is squares again. 4, then 3, 9 until the end, which is 100. The last value is 10. When it reaches the last value, it prints the last value and then it exits the loop. Now that's the end of the loop. Now let's go to the next example. Okay, sorry. Let me go back to the presentation. Okay, the scale of 1 to 10. Have you understood the loop? For loop, the scale of 1 to 10. Okay, that's better. That's better. Thank you. Let me now share the slides again. Only confirm if you can see the slides. Just use a thumbs up. You can use a thumbs up. Thank you, Ali. Okay, the next one is a vector. For I in concatenate this one, then it prints that value in the loop. I think this is quite simple. What it will output, for example, it checks the first one, it's -8, it will print I -8. The second one, 9, it will print I with 9, then it print 11, then 5. Now let's go to the nested for loop. A nested for loop is a for loop inside another for loop. Now this is what I want us to check now, and be very careful on this one. Now kindly check the syntax. Let me go back to this other one. Kindly confirm if you can see my VS Code. Thumbs up. Thank you. Okay. Now next, I want us to perform a nested for loop. Okay. Yes, my AI is doing a good job. Now, here's exactly what I wanted. For I, it's 1 to 10. Now for J, 1 to 10. These are so many. Then use exactly what was on the slides. What's on the slides here was just asking for 1, 3, for understanding purposes. And then and to print I and J. Okay, maybe I can do a small explanation what this code is doing. I'm back to the I think I should share full screen. Share screen. So I left the code instead of just copying the I'll split my screen. Okay, next. Let's go to new template. Okay. Now, let me just now this one, the first sequence for I in, sorry, my handwriting is poor, I hope you just understand. 1, 2, 3. This one means 1, 2, and 3. Now that's for the I. Now what it does, and now for J in 1, 2, I now. What do we need to do? Now, the first iteration, what I'll just explain each and every iteration. First of all, it checks the first condition. It I in 1 to 3. It takes I as 1. Yes, it takes I as 1 in this the first for loop. After taking I in 1, it goes to the next in the next for loop for j in 1 to I. Now what will be our value for, now let me do this first iteration. We have seen that I sorry, let me grab this. I is equals to 1. Then what is now j? J is for j in I to 1. So from 1 to 1, which means that is just 1. Have you understood? Let me just write 1 a better way. This means that j now is 1. So I is 1 and j is 1. So I is 1, j is 1. So if I is 1 and j is 1, if it goes to the and execute the statements, print I times j. The asterisk sign is for the multiplication sign in R. So in the first one, it will be 1 times 1, which is equal to 1. Now let's go to the second. These are the iteration. Okay, the second iteration, it now picks the next value in this sequence. I now will not be 1. I will be 2. You get it? I will be 2. Now now let's write here I is equals to 2. What about j? Next, for j in I from for 1 to I. So what's the value of j? Back to the charts. Now this one of you must try it. What's the value of j? Okay, let me just go back to my presentation. In the first, okay, I see someone raised their hand. Thank you too. Another try. Another try. Come on. Don't fear. No one will judge you for the answer. Maybe even the others don't know what the answer is. Just try. Okay, someone just said 3. Another one said 1, 2. Let me open the messages. Another try. I'm fearing. Don't fear. And then just did 1. Okay. Let me just. Okay, in this case the value of j will be 1 and 2. Now for let's check where is my cursor. Here it is. Okay, j in 1 to I. So meaning j is from 1 to I in this case is 2. So from 1 to 2, which means that j is 1 to 2. Therefore the second iteration we have I is equal to 2 and j is equal to 1, 2. Okay? That's clear. So it will be 1, sorry, not 1 but 2z I times j, which will be I, which is 2 times 1, which equals to 2, and the next one is 2 times 2, which is equals to 4. Understood? Okay, now let's go to the last iteration.
I didn't get that. I don't know what's happening there.
What's the problem? Kindly, am I not audible?
No, you're audible, but when you say I to j, and in this case I is 2. In the first case you said I to j, I was 1, so you said 1 to 1 is 1. Now 2 to j, I don't get how you're getting 1 and 2.
Oh, yeah, I'm getting 1 and 2. That's not the point. Okay. Now, let's go back to this iteration. Now, for I, in the first case, I is 1. Yeah? Okay,
Yeah.
I is given the value 1. It goes to this loop. It takes for j in 1. I just labeled it here. 1, and then these dots, 1. From 1 to 1, which value is there? It's just 1. So j is 1 dot colon 1, which is 1. Therefore, it will now the j. That's why we are giving j value 1. 1 to 1. Let me just use the rubber. Now the first iteration, let me repeat again. The first iteration, I is assigned the value of 1, and then we go to the next for loop. Okay, I got someone.
Where are you writing? Where are you writing that? Because you can't see. You just see the R. You can't see the R script. You can't see anything else.
I'm writing on this board, the paint.
I can't see it.
You can see the paint.
No.
Kindly confirm from the others. Can you see this paint, the paint screen? Use a thumbs up. If no, use a thumbs down. That's one. Ali.
Yes, now I guess Rashid is joining using the phone, most likely. And
That's not
Humphrey presented 2 screens, so make sure you are pinning the correct one. Like there are 2 screens shared.
Yeah. I've splitted the screens.
No,
I've splitted the screens. What did you see?
no, I'm saying you Humphrey shared there are 2 screens that are shared. We have Kinoti Humphrey presenting and Humphrey Kinoti. So the one for Humphrey Kinoti is having the visual code.
Let me stop presenting the around. Maybe to just clear the.
Yeah, I can see that. Okay.
Okay, I hope now you can see the paint,
Yes, I can.
and on the other side is the slides.
Yes.
Confirm if you can see the slides on the paint.
Yeah.
Now I'm writing on the paint as I'm confirming here. Okay, the first case I is assigned to the value of 1, and then j in 1 to 1. Sorry, 1. Just look at the page. Leave alone the slides. 1. Okay, this is too shallow. Use a beacon. Grab it. Yeah, put 1, 2. These are the dots. Sorry. It's a challenge. 1. Now 1 to 1. That's now j. After we assign I the value of 1, it goes to the next loop. J is equals to 1 to I. 1 to 1. Therefore, basically that's a 1. In R, that's a 1. Therefore, which is equals to 1. We are assigning j the value of 1. Now this is the first iteration. After we assign, so I is 1 and j is 1. So we go to the statement, print I times j. Then 1 times 1 is printed, which is equals to 1. Okay, now the second iteration. The second iteration, I is assigned the value of 2 inside this sequence. So it assigns the value of 2, goes to the next for loop. Now j in I 1 to I. So j with the second iteration, j from 1, this is 2, which basically means it's 1 and 2. Have you understood that? Thumbs up. Okay, thank you. Is 1 to 2. Now this j now is assigned 1 to 2, so meaning it's by 1 and 2, and I is now assigned to 2, so it will be 2 times 1 first value and then 2 times 2 the second value. Okay, now let me, I don't know if I'll add another one. Let me go next. Okay, we left for the first iteration. Say that the first iteration, it's not writing. First iteration, you have said that I is equals to 1 and then j is equals to 1. Therefore, we print 1 times 1, which is equals to 1. Then we go to the second iteration. We see that I equals to 2 and then j will equal to 1, 2. Then we go to the third iteration now. Is the one to help me here. What's in the third iteration? What will be the value of I? And in the charts. Kindly. Time is not on our side. 3. Thank you, Rashid. Yes, it will be the value of 3. Let me just continue to save on time. What about j? Rashid, you could give it another shot. 1, 2, 3. Thank you, Rashid. 1, 2, 3. Now what will be executed? Now it's 3 times 1, which is equals to 3, sorry, this comma should not be there. Then 3 times 2, which is equals to 6, 3 times 3, which is equals to 9. Now what will we have on our, in the first iteration we get 1, in the second iteration we get, where are you? Sorry, I did not, it is 2 times 1, which is equal to 2. Then 2 times 2 is equal to 4. So 1, 2, 4, and 3, 6, 9. That's the output that we expect. Now, let's go back and run our code. Okay. I hope you can see my VS Code. Let me run this command now, the for loop now, and we got the output just as what we expected. 1, 2, 4, 3, 6, 9. Now let me go back to the charts. The scale of 1 to 10. Rate how you have understood the concept of the for loop. I'm done with for loop now. Let me go back to where I need that. sheet 10, feed 10, kindly press 10. Thank you, patience. Safe, thank you, safe. Thank you. I mean, thank you for such a contribution. Thank you very much. Now let's go to the next. Let me now present this screen. Resume presenting. Kindly confirm thumbs up if you can see my. Now let me go back to the slides. Thank you, Ali. Okay. Another concept that I want us to look at, but I think is on. Kindly, I'm requesting for an additional 30 minutes. If you are okay with that, type yes. Yeah. If you are not okay with that, type no. I'm requesting for an additional 30 minutes. Just type. Ali is okay. Save is okay. Okay. Let me just continue until let me just do away the follow. We'll continue from. I want us to just do just a simple project. Now, you can also use there are two types of jump statement in R. You can use them in a for. There's a break statement and there is a next statement. What does a break statement do? Okay. A break statement, it jumps the statement. It is used to terminate a loop at a particular iteration. Okay, then the program continue outside the next statement. Obvious, after there is the for loop, there is the functions, sorry, the codes inside the for loop, and the other codes outside the for loop. Therefore, the break statement, it means that do this, and this. If you reach there, done. If you do this, done. Now the next statement, it's like now it's used to jump. It will discard that condition. Now, for example, let me use what I just in the. When the next is encountered, that iteration is discarded and that condition is checked again. Therefore, in a break statement, the condition is not checked again. It's executed. The loop is executed. It is terminated. By the next statement, it will check now the next statement. Now, I just do a visual of it. Now, this is an example. Example 1. For I in this one, now I think you all know what it is will do. I will take 3. The next iteration will take 6. The next iteration it will take 23. The next iteration 19, and then until 21. Okay, but now look at this. For I in all these elements, now if I is equals to 0, break. What does it mean? When the loop encounters a situation where there is I is equals to 0, it will stop executing. The loop will stop executing. For example, in this case, it will print I. It will print 3. It will print 6. It will print 23, 19. But now if I is equals to 0, now in this case I is equals to 0, now it will break. It will stop executing. Anything after that it will not be executed. Now here the loop exits as soon as 0 is encountered. That's all it means. Is there now the break statement, and then you go to the next statement. Now for I in all these values, now if I is equals to 0 next, now what that means, well, in the first iteration it will take 3, it will print 3. The next iteration 6, it will print 6. 23, it will print 23, until now it reaches 0. Now if I is equals to 0, it will go next. So it will not execute this one. For this one it will not execute, but now it will now go back to the loop. Now for this one 21 will be executed now, but 0 will not be executed. It means that you jump 0 and then you go to 21. Now at a scale of 1 to 10, kindly do the necessary. Sorry. At a scale of 1 to 10, the jump statements. Thank you. I think that's enough sample. I'll just, oh, Karim came. Okay, just Karim, unmute your mic. Kindly, unmute your mic. Hello, Karim. Just be specific, or I just repeat everything. So you can't hear me. Okay, let me just repeat everything in the jump statement. Thank you. There are two types of jump statement. There is a break statement and there is a next statement. Okay, what a break statement does, it checks the condition, the condition. If that condition is met, it will stop executing the hook. For example, now in this case, I in 3, 6, whatever. The first iteration, it will check on 3, it will print 3. The second one, it will check on 6, it will print 6. 23, it will print 1. But now, until 0, if now it encounters a scenario where I is 0, sorry. Now, if it encounters a situation where I is 0, it will break. It will stop executing, and that's the end of the loop. It will print now anything that starts with the loop. Now I've just used this one as an illustration that it will print anything outside the loop. Don't mind about it. Now what this one will print, it will print from 3 to 19. 0 will not print, will not be executed. Now after that it goes outside the loop, and it will print outside the loop. The next one, it's a next statement. This one is like it will jump, it will check for 1, for 3, and then it goes to 6, and then it goes to 23, it prints them. And then if it encounters a scenario is 0, for example, when it comes here, it will now jump this one, it will not execute this one, it will go now to the next. Now it goes to 21. So therefore, it jumps this one and goes back to the condition. Now that's the difference between the break and the next. So this one, it just terminates the execution if it finds this condition, but this one, it will go back to the condition. Okay, Karim, give another rating from 1 to 10. You can also give another one less than 5. It doesn't matter. Okay, thank you. Okay, I'll share the slides. We'll do this one for the sake of time. We'll do this one by your own. Okay, Grace, I hope it's now up to 10. Not go to the, or maybe we can do a small illustration on this.
Yeah. I guess Humphrey, you can just do this on the V code and then we execute them.
Okay, thank you. Let me do that.
They'll be more clear.
Kindly thumbs up if you can see my second screen. If you can see what my other friend is saying, just thumbs up. Thank you. Just do your code now. Okay, I'm using an AI. That's what is. Maybe I can make some of you did not know about it. Now this is an AI empowered by GPT-3. Okay, if just you understand what you are doing, you can just use it in your Visual Studio Code. It is empowered by GPT-3. It just makes work easier and working at a lesser time. So this is an AI which is providing me with this code, whatever. Automatically it will, as you saw what it did here, it will just give you what to write, and then you click tab, then you okay. It's easiest even it's for easier debugging. It's called GitHub Copilot. Unfortunately it's paid, but if you are a student, you can use your GitHub for student, and then you can use it for free. Let me continue. That was just by the way. Break. break and next. It's okay. You can see just suggesting for me that to use break and next. You can see for I in Python print I. You see that's a suggestion that it's giving, it's an AI. If the suggestion is okay, just accept it. It makes work easy, but in this case it's not from I equals to 10. It's a vector containing 3, 6, comma. Okay, no, not that way. You see, it's this suggesting that I use those ones, but now 19, comma, 0, comma, 21. Okay, that's okay. If I is equals to 0, okay, break. No. Let me run this code. You can see just tweeted out 3, 6, 23, and 19. But now it is a counter scenario I is 0. If we stop, if we execute the loop and start to stop. Now you can also, it will print anything that's outside the loop. Now it executes the statement. That's why it print. The loop is finished. That's okay. Yeah, you can also print the loop is finished. Yeah, that's okay. It will print anything that's outside the loop now after it breaks now. Now let's go to the next one. Let me just copy paste. Instead of copy pasting, this one will just suggest for me, so I take no stress. You see, I just click tab. It just detected from the previous one. It just thought that this was a break one. Maybe I want to do another one, and it just gives us a suggestion and you see okay. Now what we did, it will just check if I is 0, it will not print out 0, that will print out 21. Just check and run the code. That's what it did, exactly that. That's all. Now let me go back to the charts. 1 to 10 at a scale of 1 to 10. Thank you, Safe. Thank you, Chris. Thank you, Ali. Okay, that's enough. So, thank you. Let's continue. With the presentation, start sharing. And go and present back the slides. That resume presentation. Yeah, the next session on next Friday will be a better one. It will be very, very nice. So don't miss it. It will be on Thursday, I don't know. Ali will tell me the dates. Next, okay, it's a while loop. Should I go the while loop or I just... Oh, hi, thank you. I have a good illustration which we can use for this for loop. Maybe let me do this one and then we end the meeting. If you are comfortable with that, let me do it. I have to do it. So I won't take any suggestions. So I have to do this. But make sure before the next meeting you have gone through everything and you understand the loop. Okay, Ali, I've just thought something. Let me share something with you and share with the rest. I want us to just do something small.
Okay.
Yes, I've forwarded it through your WhatsApp. If you open that document, I've just imagined something which can help us understand more about the for loop. Just open that file. I want us to do something very good. How did I save everything to the desktop? So let me open it on my side. Unfortunately, this machine is very slow. That's why I'm not using it for R, because it's slow. Okay, this is the document that I want us to check on task 1. It's a boot camp that we are, and this is what we were doing. These are some of the projects that we are doing. I want us to do this one using Python and appropriate Python package of your choice. Access this link and list the top 100 mail users. Now I want to replace this one with R, not Python. I want you to replace this one with R, not Python. So what I want us to do, go to this link. Kindly, can you access the file? Yes, thumbs up. No, thumbs down.
Yeah, I've shared the file on WhatsApp.
Okay, have they opened it?
So I guess they should be able to open. Yeah, I can see Saifa received the file. Rashid.
Thank you. Thank you. That's good. Now I want us to go to this link. Let me control and then I click that link, and then it opens. Random user. Let me. Okay, this one is just some output from a random API. An API is another name is an application program interface. Application program interface. Okay, for those who are familiar with more about software development, you know this. Now this is what happened. An API is what you can't access you by yourself, but what the server, it's on the server side, not on the client side. Okay, for those who took a course in computer science, you learned about the three-tier architecture. For the three-tier architecture, there's the client side and there's the users. The client, the users, and the server. Okay, in this an API now is what the programmers use to access the server of any application, that is, let me say any application. Now this is an output of an API. As you can see, these are the results. These are a JSON file. You learned about data structures. One of them is a JSON file. You learned about matrices, vectors, CSV, Excel, and how you can control that. Now these are JSON file. It's another type of data structures and algorithms. It's JSON. JSON means JavaScript object notation. Okay, it's mostly used in APIs because of its easy to access. It's very easy to access a JSON file, and again it requires less space. If this one was a CSV file recording all this information, it would have consumed more space compared to the normal to this JSON file. This one has just a few space. Now I'm just doing this. These are just a challenge to you. Maybe some of you who don't know about this, you can just go and learn about it, about JSON files and how they are. And now what I want us to do, I want us to print these results into our data frame in R. Now I want to introduce you to something new. Everything after that you know it. Something called web scraping. Now I want us to scrape this data and then show it as a data frame in R. Now, for example, you might want to take the names of these people, but if you, from our document, you want the first 100 male users. Therefore, you want to give the condition for the gender to be male, and then all of them to be 100. Now, this is just one. This is just one from here to the end. This is just one, but now there are more. Okay. For example, how to access this one. Now it's now about the data structures and algorithms, which is a list. Now we have first of all we have this problem. How to solve it? Basically if you have a problem as a data analyst or a data scientist, the first step to do is how will I approach this problem? Now in our case, how will we approach this problem? So we'll send a get request to this web page. After we send a get request, it will give us some a response. After they give us that response, now we take the information that we need, and then we store it in a data frame in R. That's what I want us to do. And by doing this, we'll do a lot on loops, for loop, and you'll understand more about data structures. That's the main objective of this one. Then you can just save it. You don't do anything. Don't do anything. Just listen. Please. Just listen. And then after that, just go through the recording and you'll see. I want us to give it a shot. If it will not be successful, it's okay. If it is successful, it's okay. Now let me just go now to my other screen. Let me stop sharing this screen and go to the other screen. Now we do the practical now. The good thing about R is that it has packages. That's the best thing about R. It has packages. Now in Python, yes, Python has libraries too, but they are more complex compared to the R. Let me share the screen now. Let me share my entire screen. If you can see my screen, thumbs up. If you can see my screen, thumbs up. Thank you, Ali. Are you tired? Mechoka? Okay, maybe they are tired, but we will go through the recording. Let me just do another one. Let me create another file here and call it dplyr. We'll come back to my terminal. Forget about. Okay. Let me go back to my terminal. Let me add another file. Let me got this file here. Okay, now let me go back to my Visual. We'll call this here, dplyr.r. Now, the first step, I want to send the request to a web application. Therefore, each library help me with this. In R, we have a library called http. Okay, it's httpr, something like that. That will be running that right now. And again, we will be helped by our loading. Yeah, you. Require libraries, okay. Then let me just do this. Let me open this file here. Let me beyond the which is now. Let me just put this on here as well for I want to paste this on here so that our AI will be able to detect it. Control Shift C. I don't know. Okay, sorry. This will not work here. But if you are using our studio, the shortcut for commenting Control Shift C. Yeah, that's okay now. The required library in this case is library. HTTR. Yeah, thank you. This is tab. Let me run this code. Which one is it's already executed? Yeah, why is this? Is this the normal? So okay. Now this is the library that will be able to will enable us to send the request to the website. After that, you can see that AI is suggesting something. The next, you send a request. Now you send a request. You send a request to the API. Now, by sending a request inside the HTTR package, okay, should I use this? Maybe let me. Okay, if I use our studio, I think it will be just more. Let me use our studio. Let me use our studio. But unfortunately, our studio we will not have the option for this. But the good thing is that you will understand everything from scratch. Okay, an update available, no, has been deleted. Okay, no letter, yes. Okay, let me open a new project. Let me create a new project. And from a new directory, existing new directory, let me post that directory in the project. Then etc, and I choose this. Okay, then I create a project. Let me create a new file now. Let me paste what I had copied. Now this is what I have copied. Now getting data from the API. Now by getting data from the API, what do we need? We need to send a request to this API of ours, to this website of ours. Now, if you just look at the documentation of this HTTR, you can just look at it. HTTP. Okay, let me just load it first of all. Control Enter. Okay, now. HTTP hash. Okay, you can just look at the documentation it's used for making requests. There are different types of requests. There is a GET request, there is a GET request, there is a PAT, there is a POST, there is a head. You can get all these from here. It's called HTTP. Is the request methods. Yeah, some of them, there's a GET, there's a PUT, there's a PAT, and there's a head. In this case, we are going to use a GET request. A GET request, what does a GET request do? A GET request gets the response from the server. The server in this case is that website. Unfortunately, this one is the GET request. This one is not giving us information to it. Okay, go and research me about that. Let me just not do that. Go and get more about it. Go and do some research on that. Now, okay, the first thing, we put this URL in our folder. Let me, okay, control copy. You can only just use it. It is working. I'm using Firefox. For developers, Firefox is the best. Oh no, I mean that's maybe I may be biased in a way. Because actually this is what we wanted. First of the first thing we create a variable that we store this object. You learned about variables. So when we say just API, we create it now. So API is equal to. Then I store it in URL. Alt has the same as equals to. And then I create that one. That's the I store that there. The next one, there is there's some. We are told that we want the first 100, the top 100 male users. So therefore the gender must be male, and the total number, the total units, they are 100%. So we need to specify a list. We need to put this information in. So therefore, let me say, these are the parameters for here. So let me call it balance is equal to, let me create a list. Create a list. From that list, the first element I want to take, let me say results. I want my results to be is equal to 100, comma, and then the gender, I want the name gender. Therefore, I say gender is equal to name. Now, sorry, escape. Now I've created now a list. You can see that params is a list of 2, and then these ones that we have. Okay. The next is to send a request. Now let me make a comment here. Make a request. Now we need to get a response. You have to say, for any web scraping you do, you have to take the response is equal to alternate minus n, and then is equal to, I say that we are sending a get request. Well, where are we sending the request to this API, this variable called API. We are sending it to this URL, this one, and then what do you want it? You want to query this? It's in the, you can look at them at the documentation. You can see the get URL, then the config list. It has a lot of arguments. You shall not know about functions later. You will get to understand more about it. Okay. Let me say a query. I want to query what is equal to params. Okay. Next step, when I run this command, I have to run this command to see if my response is successful. Okay, let me share something small with you again. There is HTTP request codes. HTTP response codes. Yeah. Okay. 0 information. A successful response will return a response of from 200 to 299. But if there is an error, anything outside this one will be an error. Now, if it returns a response of 200 to 299, means that we can do web scraping from that. Some of them have been, you can't do web scraping from them, and to bring some more other error. Most of them they bring the current error response, which is 44. But if the response return is 200 to 299, then it's okay, we can continue. If not, no, we should not. We should do other automation methods. Like in Python, you can use the scripty package. Okay, now I want to see if this response is true. To get the response, you can just look at this list. You can see the status code is 200. Or again, you can just do it here. Response. And then this and status code. You can see our status code is 200. 200 means that successful. So we can continue. You can if it's not 200, don't waste your time continue. You use another method. It means that it has been, you can't do escaping. That is, now to that you want to get that the content in that website. First, to get the content, let me create a variable called content. With the content is equal to, I use a method called content in HTTPR package from that content we need to pass the argument x. Our x will be the response. What do we want? And then we want it to be as a text. We want it as a text. As is equal to. Then let's say we want to change it to be a text. Okay, you can run that command. You can just see the content here. It is the HTML code. You can just, if you want to see, if you are familiar with web development, this is now the HTML code used to build that website. .type HTML, whatever. Or again, you can just inspect this. You can just inspect this one, and you can see the HTML commands that just there. This is what we have now, the type HTML lang, whatever. That's what now is the content, and we have this on the text. Now, let me close this. And this is what we have now, exactly that. But the problem is that we have a lot of control L to clear the console. Now next, okay, as I told you that this type of file is a JSON file, so we need to change it from JSON to something else which we can deal with. For example, for our case, I want to change to a list, which is the default. Now to change this from a list, we use a package called JSON-lite. So I import another library called JSON-lite. If you don't have it, you can install it. Then I run that command. You can just look at in the JSON-lite package. I want to let me store it in a variable called data is equals to out JSON from JSON. Now I want to convert from JSON. This is a function. You can just look at the documentation of that. Then from JSON, you can just see from JSON, what does it do? Convert add object from to or from JSON. Now, for example, if you want to convert it from a JSON. A JSON file is a JavaScript object notation. Okay. In this case, what you want to convert from JSON is this content now. Content. What it will do, it will check in that website if there is anything that looks like a JSON file. It will take it. Sorry. JSON content. Why did you do that? Invalid car using text as okay. I think did you run this? Content. Okay, let's go ahead and invite to looking to type. Why is this there? Let me just think of how we cancel that error. Actually, I don't know why it repeated for this error. This one should not execute this. It should not bring these errors. I don't know why it's then. I find that method get okay. Okay, I'm just trying to solve this error somewhere else. Okay, I don't know why it's bringing an error on this side, but it should not bring this error. Okay. Content customized for us is equal to text. These problem. We need to clear these tags, these HTML tags around which have been prepared. I think there's a way which we should do this. as because we do exactly this. I think this what now it didn't. There's a problem with this code there. Again, it's the same get API query is equals to count results is 100. Okay, do that time.
I guess the error is on the content.
The error is on the content, but
the data type is, I don't know, HTML from the environment.
Let me check it here. Okay, I have to clear these. I have to get rid of these things. And I get. Okay. Okay. It's not the issue of being these. Okay, let me just look at that point. I'll just check the area which I'm supposed to. Let me check the success. Content. Yeah, the error is just from the content. Okay, let me just try it as something else. Okay. From this one. Let's go and code it as txt. Flatten. Let me just try flatten because to true. Okay, let me try that. Flatten. It's flatten out. Let me try this and see. Not yet. We need to get rid of these tags. That's what I'm trying to do.
What about when we check the documentation of the content itself?
Okay, the content is okay. The content. Okay, yeah, that's. Oh, by there I took from. Oh, yeah.
So that now we can check on the arguments that are there, the as and such.
Type is equals to encoding. Text content. It does not have this text.
Yeah.
Let me try row. Let's see. Oh no, these are worse. This is very worse. Okay, automatically process the JSON. Let me try these. Oh, let's try these and see. Text, then comma, Try to not yet. I think if you run this on a Windows machine, it will remove the. It will remove the.
Most likely. Maybe you will share the codes with us, and then we try to execute from our end. Because from the documentation, it is very clear that that error is not supposed to be there.
That error is not supposed to be there.
Yeah.
Okay, just. Encoding. Ali, just end the recording. We'll move on.
Okay.
Thank you guys. We'll continue there from then.